Welcome to the fourth episode of my tutorials on Circos for bioinformatics. In this video, I'll show you how to generate this Circos plot here. Now, this is a Circos plot of a microbial genome, to be specific, a Mycobacterium ostrans isolate. All right. The plot comprises of the GC content, GC skew, and the distribution of high impact variants. All right. Now, this is a single chromosome. And if you want to highlight certain regions of the chromosome, you can do that by using custom colors, like in this particular plot here. So that's what you need to know. I'll show how to get example data for this tutorial, so don't worry. Now, if you want to follow this tutorial, you need to make sure that your PC satisfies the requirements here. So you should have a Linux or macOS system. You should have Circos installed, BCF tools, and you should also have Python installed. Okay, and this Python library should also be installed. Now, for these packages, okay, instructions for installing them can be found in the description box. So just make sure to check the description box and use those tutorials to set up your PC. Now, let's get started. So first of all, you need to make sure you have the input files. So I have mine here. The link to get these files can be found in the description box. I've prepared some of the commands beforehand, so you don't have to do that. Okay, so in principle, the script here can also be applied on other data sets as well. Okay, so if you have a data, okay, which comprises of a single chromosome, or let me just put this way. So if you have another microbial organism, you have the genome, okay, and it's a single chromosome, you can apply the script here to that organism as well. You can also contact me if you have any challenge. I'll show you how to repurpose the script. Now let's proceed. So let's do this. So I have the input files. So this is one of them, a GenBank file. This is also a VCF file. So if you have your microbial isolate, microbial genome, if you have the isolate, you perform genome assembly, and do some quality control, do some checks, and you can also do genome annotation. When you perform genome annotation, then you get this GenBank file, okay, which has some information that we use. All right. Now I have tutorials that show how to perform genome assembly, genome annotation, etc. So basically, if you have a microbial genome, then I have tutorials that can help you get started. So use those tutorials to obtain this file. Okay. I also perform variant calling to get the SNPs. Okay. I perform variant annotation. So what you have here are high impact variants. Okay, that's what you have here. So I'm going to look at the distribution. So I use SNP-EFF to annotate and obtain the high impact variants. Okay, so for SNP-EFF2, I have tutorials that show how to use them. So check the description, you'll find links to those videos. So I have them here. Now with Circos, you also need to get some additional files. Okay, so these files by default you have to generate them, okay, from custom scripts. All right, so I am going to extract the GC content and GC skew from this GenBank file, and then I will extract the variant information or distribution from this VCF file, and then after that we will generate the Circos plots. Okay, so that's what you need to know. So first of all, we have our GenBank file. So let's extract the GC content and GC skew. So I have this Python script to help me do that. So I'll open it first. Then this is it. All right. So again, make sure you have installed BioPython. Now these commands are used to import the appropriate libraries. We also have this, and then we have this file here. To specify the GenBank file. So this is the only thing that you have to change if you are going to use a different data set. So the file name is what? Let's check. It's p7741.gbk. So that is what I have specified in there. Okay, so if you don't see this, make sure to type the name there and then put it in double quotes or single quotes like I'm done here. Okay, so that's all that you need to know. The rest of the codes are used for processing. Okay, so let's run this. So first of all, let's run this code to get our input files. Okay, that has been done. So nothing will be displayed here by default because I made it that way, but I think I'll modify it so that when you download, you see some files or some text being displayed. That will help you. Right? So this script generates 3 files, which are here. We have GC contents, GCSQ, and then the character, the TST. Now for character, I've explained this in other tutorials. So just check my Circos tutorials, you'll find explanations for the character, the TST. Of course, we will look at that here. So GC contents, this is it. So I have the chromosome, and then this one, I use a binning. So I looked at the regions. Okay, so this is 1 kilobyte window. That's what I used. Let's check. I think, yeah, it's 1 kilobyte window. So the chromosome, for every 1 kilobyte region, I computed the GC contents for that. That's what we have here. So that's basically what you have. So this is the format that we use in Circos. And then for GCSQ2 is the same thing. I use a 1 kilobyte window to get the values. And then the karyotype, let's open it. I also have it here. So karyotype is used to display the chromosome. Okay, but I also added something here just to show how you can highlight certain regions. So I added a band information. So that's what I have here. Okay, so these are the inputs that will be generated by the GenBank to Circos.py file. This Python file here. That's what you have. Now we need to add the variant information. Okay. So we will use this. Okay, but first we have to extract the information using BCF tools from the SNPs, and we process that file to get our final output. So I'll do this. I'll open my terminal. I'll first do an ls just to make sure I have the files. Okay. So let's do this. Okay, so I have my file. So I'm going to extract some information from the BCF file. So I'll use BCF. So I'll extract the chromosome number and then position. So I'll say BCF tools -f. I'll bring a quotes percentage and I'll say chrom. I'll say /t percentage again post. I'll say /n. Now close it. So after specifying this command, we need to also specify the BCF file. Okay. So I'll have to say snip.bcf like this, and then I'll redirect the outputs, okay, to a file. I'll direct the result to a file. So I'll do this and I'll say variant info.txt. So I'll run this. Perfect. So if I do an ls, I'll find a file called variant info.txt. And do a head, display some contents. That's what I have. Now, with this format, we need to add an additional thing. We need to add a header. Okay, so let's clear the screen. Let's do a head again. We need to add a header. Okay, let's even view the file here. So there is it, but I need to put a header there. So there's the chromosome, there's the position. So I'll still do that on the terminal. Right, so I'll come back here. So I'll say sed-i. That means that I'm applying the changes on that same file. I'll say 1i. I bring a quotes and I'll say chromosome /t for tab, say position like this, and I'll specify the file to variant info.txt. So I'll execute this command. So now if I do a head, I'll see the header there. So there's what I want. Okay, now let's get back here. Now we have to do this. Let's see. Let's go back there. Okay, so this is it. All right. Now I'll need to process this file to get a final output. So I'll use this one here, snip EFF to Circos. So I'll open this Python script and then I will specify the file name here. Okay, here it's already there. It's this one, but if you don't see this file name, put the appropriate name there. Right? So you should have something like this. And then you can run the Python script to generate the file. Okay. So now if you go back here, you find a file called, let me just open it here again. You should see that file being displayed. Let's check here. So you should see a file called high impact underscore variant.txt. So I'm going to rerun this to generate that file. Let's do it again here. Okay, so I'll check it out. So I should see the file. Now, if I don't see it, I'll just go back. I think I'll do it. So let's see. Yeah, okay. Yeah, so the file is here. So there's the file. Okay, so you should see this file also generated. So these are the things that you need. Okay. After that, you can run Circos. Now for Circos, you need to also specify some information. You need to set your formats. You need to specify colors, etc. So all these things, I have done them, okay, in separate files. So you have the ideogram.conf, you also have the text.conf, and then you also have circles.conf. So all these ones are needed. So I've done all those ones, so you don't have to do that. So all I have to do is to just check the files just to make sure they are not empty, and then you can run Circos. Okay, so here's the circles.conf. So let's open this, and then let's also check something. So when you open this, you don't have to modify anything. You just need to check the plot session. This one, check and make sure that you have the g6q.txt here. Okay, line 26, this one here, or 25. So file equals g6q.txt. That's the first one. And there's a second plot. Make sure that one is gc contents.txt. All right, that's what you need. And then check the third one, which is the links. Make sure you check and make sure that the file here is high impact underscore variant.txt. So these are the outputs we generated. So you have gc content, this is key, high impact variant. Okay, so those are the things that you need. You just make sure those are there, and then that is it. Okay, so once you've checked and everything is okay, then you can run Circos. So let's go back here. I'll open the terminal. Okay. Now what you can do is to run Circos. I'll say Circos -conf, and I'll say circos.conf. Let's check to make sure that everything is there. Let's do an ls first to see. I'll just check here. Let me open a new terminal. I'll just see. Yeah, perfect. So I'll say circos-conf, say circos.conf, and I'll execute this command. So once I do that, I'll have to wait for the plots to be generated. That's what we need to do. Okay, so you will proceed. Now, what you should also note that with Circos, if you create your input files, then some of them go beyond the length of the chromosome or the bands or those data points. Okay, they will be trimmed. I repeat, if some points go beyond the length specified in the files, they will be trimmed off. Okay, so that will come as a warning. So you just make sure you specify the correct values. So now we have the plot generated. Let's go to the screen. Let's do an ls, and we are going to find a png file and a .svg file. So I'll just come back here and check them out. Okay, so I'll just do this. I'll just refresh this particular page. I'll do it this way. Okay, so I have the output file. So I have them here. Okay, so I have the circles.png, which I can open to see the file. Okay, so there's it. There's a cool plot here. Okay, so there's how we do it. And then let's check. We also have the SVG. So the SVG, you can open it with tools like Inkscape, tool that supports the vector graphics. So I have Inkscape, so I can open it with Inkscape, and then after opening, I can do some modification. Okay, so Inkscape helps you to modify images that are in this format. So like have it this way. So once I have it, I can do some modification. If, for example, if this text here, I want to add something, I can just add it. Let's say, yeah, you can add some files to it. Okay. So all those things can be done. That'll be it. Okay, but a detailed description or explanation of how to use Inkscape is beyond the scope of this tutorial. Okay, so those are things that we cover in other tutorials. And of course, you also know that the images, if they are large, then editing with tools like Inkscape can also be a bit slow. Okay, so that's what you need to also take note of. Okay, but once you open it like this, you can edit and then later add some modifications to it. So that's it. All right. So I'll just exit this one and then that's it. So that is it for this episode of Circos. So if you have a microbial genome, okay, a single chromosome, then you can try to use these materials to generate the plots. Okay, so this is how I bring this to an end. Okay, so you can check this playlist here to find more tutorials on Circos.